All right, so right now let me go to the list processing in simulation. This one, list processing. And actually this processing, it doesn't mean in simulation. In general situation, possibly you can have this processing. But because of EMI in our course in chapter 1 and currently in chapter 2, we will have list processing naturally for the natural way to have the simulation. So it says, example in our previous chapter, chapter 1, we have this one. In fact, we can have no list of records. All right, not event list. And also we use first in, first out. So even we have a list, we use first in, first out. But we can remove first in, first out and say, oh, okay, I want to retrieve the second one, not the first one. Therefore, we have the different order of list processing possibly for the list processing. So at least, maybe we don't use the list. And maybe we don't have the different order. So right now we try to generalize to have the list, to have the list processing. If we have the list processing, then it won't be necessary to have the first in, first out. We can have last in, first out. We can have the others. Even we don't have the demonstration, but this will show you, yes, don't forget we can apply this processing in the simulation. So look at this. Most complex simulation require many lists. That's true. And also not in, first out manner only. List processing. Here we want to have the list processing. Before that one, we gotta have sequential allocation. So this one, it's array. And next one, actually, we have a link allocation. All right, link allocation, actually, we have records contain pointers. So pointers, because we have a list and point to the next one, so we need to have the pointer. Pointer, it doesn't mean in the classroom I use a pointer. No, it's a specific data structure. We have pointers. And in C, we have the concept of pointers. No problem. Well, so pointer will specify the logic relationship to the next records or the previous record. All right. And actually, if we use this processing, actually we will have an advantage for simulation modeling. It's a natural way to have the simulation modeling for sure. For example, here we have two directions. So this is first one. And this is a reverse direction. So we have a head and we have a tail. All right. Of course, we can have the record. Right now, maybe we don't have any physical meaning. But, oh, okay, we already know we have the purpose we call the quantity. Maybe 10, 15, 25. They are the possible records you are interested in. And the next one, we simply have a head. And want to go to the final one. It seems to be, oh, okay, just one direction, and then that's enough. But sometimes we need to have the reverse direction. Alright, so normally we should have the reverse direction. So this one, it will be the suitable one to have two directions. I think right now, I just want to mention those concepts taken from data structure. And also C programming language. So if you think you need to look up, go and check it. Data structure or C programming language, and then you can have all of this. Specifically for the list, for the linked list, in fact, you need to know some maybe way to define or maybe some notations in C programming language. So go ahead and you can check them, and so that you know how to have the linked list. Therefore, I want that you know some details about data structure and some details about the C programming language specifically to the linked list. All right, and right now, let me try to let you know the advantage of linked allocation. All right, so why linked allocation? Because time can be reduced. Is it true? Time can be reduced? Actually, for the processing, possibly time can be reduced. Because if you know, oh, next one, point to the next one, it's the right direction. And then it won't be necessary to have the procedure to determine the next event. And this is the next record. So you can proceed to the next record easily. Because of this, it says time can be reduced. And next one, well, compared to array, how about the link or event list processing? If I will talk about queue, so queue point to the next one, point to the next one, and point to the next one. And maybe we have a tail point to the previous one. And so we have the preparation for the processing. So it won't be a problem. And so that we can speed up event list processing considerably if we have the good preparation to this type of processing. And about memory setting, why memory can be set if indeed, oh, okay, we have a space here. Maybe here we have a 1, 2, 3 only, but 1, 2, 3, 4, for example, to 10 or maybe to 100. Right now, we just occupy maybe three records. It doesn't mean we need to occupy 10. So if we have an array, we have the pre-allocated memory. And for linked list, no, it won't be necessary. So of course, we can reduce the memory. And finally, it's a general framework if we talk about queue. All right, a system involving the queue implementation. Then it's a general framework, no problem. Because of this advantage, so we suggest you to use the linked allocation.